In today's video, we will be going over learning target 3, which mainly relates to trig functions. So the first question is asking us to convert from degrees to radians. So we are given that the angle is 40 degrees, and we need to get this into radian form. So the simplest way to do this is to multiply it by pi over 180 degrees. More specifically, pi radians. We're allowed to do this because for every pi radians, you have 180 degrees. So this is basically, this right here is equivalent to 1. So now we just need to multiply this out. We have 40 times pi over 180. And the degree symbol basically cancels out. So we have 40 pi over 180, which can be simplified to 2 pi over 9. And that is our angle in radians. So part B is asking us to evaluate a few trig functions. So what I'm going to do first is I'm going to draw a circle, more specifically a unit circle. Oh, if it lets me draw a circle. Okay, that's a circle. And I'm going to give it some axes. Now this isn't really that necessary, but sometimes I think it's good to visualize the unit circle when you're solving these trig functions. So we're given that theta is equal to 7 pi over 6. So our pi over 6 points will be here, and here, and here, and here. That's just something over 6. So this is 7 pi over 6. We know that this is equal to 0, and this is equal to pi. So 7 over 6 is a little bit greater than 1 pi. So I'm going to think that this goes right here. And it's asking us for the sine of 7 pi over 6. And sine relates to the height, or the corresponding y value. And that will be -1/2. So this is equal to -1/2. Now we're finding cosine of 11 pi over 6. And 11 pi over 6 is just smaller than 2 pi. So we will end up over here. And cosine relates to an x value, the corresponding x value at this angle, which will be the square root of 3 over 2. So that's our answer, the square root of 3 over 2. Now for the next one, tangent of the 3 pi over 2, we'll be going to our over 2, or some pi over 2. And 3 over 2 pi is going to be between pi and 2 pi, so we can pretty intuitively figure out that that goes right here. Now tangent relates to the slope, the y over x. And when we're at this point, the slope, it's just a straight line up, which is not possible, so we write this as dne, because the slope is undefined. Now we're asked to find secant of 3 pi. This may be a little confusing at first, because we aren't typically as familiar with secant and cosecant and cotangent, but it's good to remember the rules, and we can rewrite this as 1 over 1 over cosine of 3 pi. Now, starting at 0, if we go around the circle once, that's 2 pi, and then 1 more pi, we end up over here. And we know that cosine I'll just write this as cosine of pi now. And cosine of pi is equal to -1 because that's the x value that corresponds there. So we have 1 over -1, which is just -1. And then finally, we need to find sine of -3 pi over 4. Now we know that our pi over 4 values will be the equidistant point between each quadrant. So that's something over pi over 4, pi over 4, and pi over 4. But we have a negative sign here, which means you're going to be going in the opposite direction, like that. So 3 pi over 4 is a little bit less than 1 pi. We're going in the opposite direction, so we will end up right here at this point. So this will be -3 pi over 4. And the sine and cosine value will be equal to each other here in this or in the third quadrant, both values will be negative. So this will be equal to -√2 over 2. Finally, in this last part, we are given a relationship that the cosecant of theta is equal to 5, where theta is an acute angle. This just means that theta is going to be less than 90 degrees, which is pretty standard for a problem like this, so I wouldn't let that confuse you. And we need to find these 5 trigonometric values. And it recommends that we set up a triangle. So let's definitely set up a triangle. Okay. So theta is going to be less than 90 degrees. Let's just say theta is right here. And we know that cosecant of theta is equal to 5. And cosecant is the same as 1 over the sine of theta. So 1 over the sine of theta equals 5. And then rewriting this again, we have sine of theta is equal to 1/5. And sine relates to the opposite over the hypotenuse. So our opposite value will be 1, and our hypotenuse will be 5. But now we also need to find what this leg right here will be. And we can do this by using the Pythagorean theorem. So we have that, let's just call this, let's call it x for now. So using the Pythagorean theorem, we know that x squared plus 1 squared is equal to 5 squared. So that means x squared plus 1 will be equal to 25. So x squared is equal to 24. And then taking the square root of both sides, we will have that x is equal to the square root of 24. So now we have all 3 sides of the triangle, so this makes evaluating this question a lot easier. So sine of theta is equal to the opposite over the hypotenuse, which will be, and I'll just write this as the opposite, this is the hypotenuse, and this is the adjacent. The opposite over the hypotenuse will be equal to 1/5. And then cosine of theta is equal to the adjacent over the hypotenuse. So we will have the square root of 24 over 5. Tangent of theta is equal to the opposite over the adjacent. So we will have 1 over the square root of 24. For questions like this, you don't need to worry about rationalizing a denominator. Secant, we talked about that in the previous problem, is the same as 1 over cosine of theta. And cosine theta is equal to the adjacent over the hypotenuse. This means 1 over cosine theta is equal to the hypotenuse over the adjacent, which will be 5 over the square root of 24. And finally, cotangent of theta is equal to 1 over tangent of theta. And tangent of theta is the opposite over the adjacent, So 1 over tangent theta will be the adjacent over the opposite, which is just the square root of 24. So this is the completed learning target. Come to office hours if you have any questions.